These students, we will talk about chromophore and auxochrome, a very important concept in UV visible spectroscopy. As we know that the organic molecules have various kinds of electronic transitions like pi to pi star, similarly from N to pi star if they have lone pair of electrons and pi bond. These are two prominent electronic transitions, and these transitions are only possible if a molecule has pi electrons, and these are possible if it has pi electrons as well as lone pair of electrons or n electrons. For example, if we have carbonyl group, we have a double bond which is a pi bond, so pi to pi star transitions are possible, and there is a lone pair of electron on oxygen, and that lone pair presence can cause N to pi star transitions as well. During these transitions, either UV or visible electromagnetic radiations are being absorbed. So the absorption is because of these groups. So chromophores are the part of molecule which can absorb these radiations via pi to pi star or N to pi star transitions. Technically speaking, the name chromophore comes from the group which imparts color to the molecule, which means that molecule will absorb in visible spectrum. But generally speaking, a chromophore is a group of atoms having these multiple bonds and lone pairs by which pi to pi star and N to pi star transitions can occur. And if that occurs in visible region, it will be colored, and if that occurs in the UV region, it will be colorless. But regardless of this, it will be chromophore. Various chromophores which can be taken as examples are like carbonyl, which absorbs at 280 nanometer. We have benzene ring, pi electrons as chromophores. We have 255 nanometer as lambda max. So it could be like extended conjugation. We have nitrogen-nitrogen double bond, so 262 nanometer is the lambda max for this very chromophore. And we have N double bond O, 270 nanometers, and C double bond SR, thiocarbonyl, 330 nanometer is the lambda max. So these are the groups responsible for absorption of UV or visible radiations. Now we will talk about auxochromes. Auxochromes themselves are not chromophores, and technically speaking, we can say they do not have pi electrons by which pi to pi star or N to pi star transitions can occur. This is a very technical understanding, but they do have N electrons or non-bonded pair of electrons. Some examples of auxochromes are like this OH group. So this OH group is having electron pair on oxygen, but there are no pi electrons available. Similarly, O with alkyl group, alkoxy group, methoxy or ethoxy. Similar condition R is replaced with H. We have amines and secondary and tertiary amines as well. And we have SH or thiol group. Now these group of atoms which we have referred to as auxochromes, they themselves are not active in UV or visible because of the absence of pi electrons, but when these are attached to a chromophore, when these groups auxochromes are attached to a chromophore, they will change the nature of that chromophore in a sense that its lambda max will be shifted or changed, and usually they enhance the lambda max towards longer wavelength. And not only the lambda max or the wavelength of absorption of that chromophore will change, its molar absorptivity will also be affected. We can have an example here that we have a benzene molecule whose lambda max is 255 nanometer with an epsilon value of 203. If we attached an auxochrome NH2 to the benzene ring, which will make it aniline, having lambda max at 280 nanometer instead of 255. So lambda max is shifted towards longer wavelength, and the epsilon value has also changed from 203 to 1430. So we can say auxochromes, when attached to the chromophores, means the properties of that very chromophore, which was the initial one, has now been changed because its lambda max is changed and its epsilon value is changed. So these are the auxochromes. Again, they are not chromophores by themselves, but if they are attached to some chromophores, they will change its properties in terms of wavelength of absorption as well as molar absorption. I hope this clears the concept.